Hello, welcome to this Operational Excellence video. Today we will be learning about takt time, cycle time, and lead time. We will examine the three different times and explain how they are related and how they differ. Knowing what these terms mean and how and when they apply will help you understand and design your processes to better meet your customers' demands. First of all, let's look at takt time. Takt time is a calculated value that describes the theoretical demand rate of your customer. In other words, it is the rate at which you need to produce in order to meet their demand. Takt time is calculated by dividing your available production time by the number of units your customer needs. So for a single shift operation running 7.5 hours a day, 20 days a month, you have 150 available hours, or 540,000 seconds. If the customer needs 20,000 units, the calculated takt time is 27 seconds. So in order to meet the customer demand, one unit will need to be produced every 27 seconds, at a minimum. Takt time is useful to get a gauge on what is actually needed in order to meet your customer's demand. But it would not be wise to run it exactly 27 seconds unless you know your process never has an issue. Most operations know there are going to be issues, especially early in their learning curve. As a result, they plan to run faster than their takt time by a certain increment to allow for some downtime. This would be their targeted cycle time. Cycle time is the rate at which your operation is actually producing a unit. Cycle time is measured as the frequency of units produced. So if you're watching a process, the cycle time is the time it takes from the output of one unit to the output of the next unit. You can continue to measure those cycles, output, 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 etc., to determine how reliably your process is able to meet its cycle time. Producing at a consistent and predictable cycle time indicates a stable process and allows you to see abnormalities quickly. Lead time is the measurement of how long it takes one unit to make its way through your operation, front to end. You measure the lead time by watching a unit enter the operation, following it through the entire process, and stopping when it leaves the last step. Lead time is a useful measurement in two ways. First, if your product is a made-to-order product, it tells you how long your customer has to wait for their unit to be completed. Secondly, it can be a gauge on how much inventory is in your process. If it only takes 5 minutes worth of effort to produce a product, but the lead time is 5 days, that means your operation has a lot of inventory between every step, delaying the output of the work. Value stream mapping can help highlight where those inventories are located. To understand takt time, cycle time, and lead time further, let's look at a scenario and apply the terms as we go. In this scenario, we have a small company that produces colored circles on white paper. The operation requires 3 work steps: tracing, cutting, and adhering. Step 1, tracing, outlines the circle to be cut. Step 2, cutting, cuts the circle. Step 3, adhering, attaches the circle to a sheet of paper. The company has 3 employees, 1 on each step. Currently, the company has 1 customer that regularly orders 36,000 units a month. If the company ran a 7.5-hour shift per day, what would the takt time be? Let's review the takt calculation again. Takt time is the calculated demand rate, available time divided by units needed. The available time in a 7.5-hour shift is 27,000 seconds. Multiply that times 20 days in a month equals 540,000 seconds in the month. So our available production time in the month is 540,000 seconds in this scenario. To get takt time, we need to divide 540,000 seconds by the number of units ordered, or in this case, 36,000. When we do that, we get the takt time of 15 seconds per unit. This company will need to produce 1 unit every 15 seconds during their 7.5-hour shift to meet their customers' demand. Now let's watch the process to see how we do. Let's measure the cycle time of the operation. To do that, we simply have to measure how frequently one unit comes off the end of the line. Let's measure. Output. 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 When we measure the cycle time, we get roughly 13 seconds. Do these times meet our takt time? Yes, they do. If we continue to run at this pace, we will meet our customers' demands. Now, let's evaluate the cycle times of the individual process steps with enough inventory to let them run. Let's watch the output of tracing. Output. 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 Now let's watch cutting. Output. 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 And lastly, adhering. Output. 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 The cycle time of tracing is 6 seconds. The cycle time of cutting is 13 seconds. And the cycle time of adhering is 6 seconds. After examining the individual times, it is clear that the output of cutting is far slower than the other two steps. What was our takt time again? Correct, 15 seconds. Even though cutting is slower, it is still meeting our takt time. So as a whole, the process is meeting takt time. Looking at the timings of each step, are there ways to improve this process? Sure. The first and last step could be combined and still meet takt time. Another option would be to have 2 cutters, which could bring the overall process cycle time down to 6 seconds. In this scenario, the additional speed is not required, so the first option might be preferable. Here we have our combined cell. The first operator is tracing, handing it to the second operator for cutting, and then adhering the previous circle. This balances the work content between the two operators. Now let's change the scenario a little bit. Because the company improved the process and reduced its cost, another customer has decided to order some units. This customer requires 36,000 units a month as well, but will need their units completed in 30 seconds to serve their customers. So from the time they put in an order, they need to receive that unit within 30 seconds. Because we have more volume now, we need to recalculate our takt time. Once again, takt time is the available time divided by units needed. The company's available shift time is still 540,000 seconds a month. The number of units needed is now 72,000, 36,000 from each customer. So our new takt time is 7.5 seconds a unit. Remember the improvement options we had? In the first option, we could combine the first and last step and end up with a 13-second cycle time. In the second option, we could add a second cutter and end up with a 6.5-second cycle time. Another option could be to combine the first and last step and run 2 cells to still end up with a 6.5-second cycle time. Another option would be to run 2 shifts of the combined cell, increasing the available work time. The cost of equipment and the space it requires might dictate which of the options we select, but running 2 cells would give us more staffing flexibility. So let's select that option. Now we have two cells running with tracing and adhering done by the same operator. Let's measure the output cycle time of each cell, starting with the cell on the right. Output of the cell, output of the cell, output of the cell. This cell is producing at 13 seconds a unit. Now let's look at the one on the left. Output of the cell, output of the cell, output of the cell. This cell is producing at 13 seconds as well. With two cells producing a unit every 13 seconds, we effectively have a unit coming out of our operation every 6.5 seconds, which meets our takt time of 7.5 seconds. Now let's measure the product lead time. If customer 2 orders a unit, will they get it in 30 seconds? To measure this, we'll select a color to follow through the process. We'll select green. As step 1 grabs a green sheet, we'll start the clock. Now we watch it as it goes through the entire process, tracing, cutting, adhering. When adhering is done and puts it into the completed pile, we stop the clock. In this case, our lead time was 21 seconds. Because our customer needs these orders within 30 seconds, a 21-second lead time will be sufficient. If our lead time was greater than 30 seconds, we could value stream map the process to look for ways to eliminate inventory. We have looked at two different scenarios: calculated takt time with different volumes, measured cycle time to see if we are meeting our takt time, and measured lead time to see if we are meeting our customer's SLA. Now that you understand how to measure your process with takt time, cycle time, and lead time, why don't you go and measure your own process? You might be surprised at what you find.